Hello, and welcome to what is hopefully a new CNCM series in covering Aime problems. And what I have here today is one of my favorite problems from yesterday's 2020 Aime 1 test, and that is problem number 10. So here we have the problem here. Let m and n be positive integers satisfying the conditions. The GCD of m plus n and 210 is 1. M to the m is a multiple of n to the n, and m is not a multiple of n. So we want to find the least possible value of n plus n for this problem. So first off, look at the first condition here. It doesn't seem to limit our possibilities much. There's a lot of pairs of integers m and n that would work for this. So let's take a look at the second and third conditions, shall we? So we have that m to the m is a multiple of n to the n, and which means that n to the n divides into m to the m. All right. Uh, But our third condition says that m is not a multiple of n. So n does not divide into m. Well, looking at this condition, you may be thinking, how would this be possible? So let's think about how this would be possible. So let's say that a certain prime factor p divide n, but m didn't have that prime factor p. Well then, that would satisfy this condition over here. Let me just write this. P does not divide into m. If we had this, well, this satisfies our condition over here. However, when we raise this to the nth power, we'll have some multiple, we'll have a lot of factors of p, basically. It depends on the number of factors of p and n, but we don't really consider that because m doesn't have any factors of p to start with. So even if you multiply m times, you won't get a factor of p. So this would actually not hold true if that was the case. So let's think about this more. Let's say that p divides both m and n. Let's say that n contains two factors of p. So let's say that n has a p squared in its prime factorization, and let x be the rest of its prime factorization. And let's define m to have, p times y, and then y being like the rest of its prime factorization. And obviously we'd have to have x dividing into y for the condition to even work, so that's implied here. So this satisfies our first condition here. N does not divide to m because n has more factors of p than m. However, we can see that if m is large enough such that m to the m will have more factors of p than n to the n, then this will actually work out for us. So that's interesting. We want to keep that in mind. So this might actually work. So let's go ahead with our normal definitions again that we defined. We have p squared times x and m equals p times y. So let's test this. And since we want to minimize the sum of m plus n, we're just going to keep the factors p squared and p, not something like p cubed times p, because that's going to make our n larger, and we don't want that. So this is the most minimal way to satisfy this problem. So if we sum these, uh, that'd be m plus n is equal to p squared x plus py. You can factor out a prime p from here, which makes this px plus y. And why is this important? Well, we want to choose the least possible p so that we can minimize our sum. However, we have that first condition here, as you remember, GCD m plus n and 210 is 1. And the prime factorization of 210 is 2 times 3 times 5 times 7, which means that if you want to pick a minimal prime p, we can't pick any of these. So the next possible lowest prime is p equals 11. So we have our prime number now. So let's keep in mind that we want to minimize our sum. So let's just let n equal 11 squared. Let's not have it have any other prime factors. And now let's look at m. So m has 11, and it has something multiplied by y, because if it was just 11 alone, then this would be 11 squared to the 11 squared power, and this would be 11 to the 11th, and this will obviously have more factors of 11. So you want to have something here that's added. So using these, let's go to the next slide here. N equals 11 squared, and m equals 11 times y. Our n to the n will return 11 squared to the 121 power, because that's 11 squared, and that's actually going to give us 11 to the 242. So n to the n has 242 factors of 11. Now we want m to have greater than or equal to 242 factors. So we know that m to the m is equal to 11 times y to the 11y. So just considering 11 here, we're going to have 11 to the 11y factors. All right, so we want 11y to be greater than or equal to 242, because in that case, n to the n will divide m to the m. Well, let's test this here. This would actually give us y is greater than or equal to 22. So going back to our sum, let's look at our sum here real quick. Our sum would be m plus n. Hold up, sorry. Just want to see if I have more space. M plus n. You know what? Let's just move to the next slide. So m plus n. So we already defined n as 11 squared, and we defined m as 11 times y. And so from the last slide, obviously, so we got that y is greater than or equal to 22 for this to work. So summing these, m plus n is equal to 11 squared plus 11 times y is also equal to 11, 11 plus y. So our minimum value of y is 22. However, if we actually substitute that in 11 times 33, we fail our GCD condition because this is actually divisible by 3. So let's try the next highest integer value of y. That would give us 23. That would give us 11 times 34. And that has a factor of 2, that won't work. If we try 24, that'll give us 11 times 35, and that won't work either. If we try 25, y equals 25, we'll get 11 times 36, and that will not work either. If you try 26, we will get 11 times 37. 37 is prime, 11 is prime. The GCD condition is satisfied. We have that 11 squared does not divide 11 times y, n does not divide m, but we do have that n to the n divides m to the m because we have enough prime factors in m to the m by solving this problem. And we've tried our best to, well, we've basically minimized as much as possible throughout this process, and we can be confident that this is our answer. So the problem, always want to go back and read what it asks for, find the least possible value of m plus n. And so our answer is 11 times 37 equals 407. And that should be it. Thank you for watching. And please, if you're interested in joining our math group CNCM, we have a Discord server, and I will link that in the description below. Please do check it out if you're interested. And thank you for watching. See you later.